We are continuing our work with parabolas. This time, though, we are going to shift that vertex away from the origin. Okay, so we're going to look at how do we graph them and also how do we write equations for them. My suggestion, as it was last week, sketch it out. All right, if you're given some information, plot it on a grid so you can kind of see which type are we working with. Is it the x squared kind or the y squared kind? Is p a positive or a negative value? That kind of thing. It says when a parabola with the equation x squared equals 4py or y squared equals 4px is translated horizontally h units and vertically by k units, the vertex of the parabola moves from the origin to hk. Such a translation does not change the focal length, the focal width, or the direction of the parabola, whether it opens up or down, left or right. Okay, so looking at our sketches here, we're looking at both an x squared kind and a y squared kind, and just that idea of if we shift the vertex, it is now at this point hk, the focus is still going to be p units from it. Okay, so p units going up means we have changed the y coordinate by p units. If we're moving it left or right, we're changing our x coordinate by p units. Yes? The chart at the bottom here just summarizes all the information regarding parabolas that have been translated. Again, I'm not expecting you to memorize the chart. I would much rather you understand where things are coming from than saying, oh, I have to memorize that if it's a left or right, it's this kind of directors. Okay, much better to just visualize what it looks like. Okay, so we are not going to be working with x squared equals 4py anymore. We're going to be looking at that translated one. So these are the ones that I would say to memorize for parabolas. All right, don't memorize the basic one and then the translated one. Just keep this one in mind. Because if the vertex is at the origin, the h and k just drop out. Okay? All right, so these are the ones that I want you to memorize. X squared, remember, opens up and down. Y squared is the ones that go left to right. Okay? Keep in mind that P in our equation stands for the focal length. In other words, that directed distance from vertex to focus. The absolute value of 4P still represents that focal width. So when we think about graphing a parabola, we've got vertex and focus. The focal width is this distance. Okay, let's pretend that one goes through the focus there. Okay, the distance from this point to this point is your focal width, right? And that's going to help you know how wide to make your parabola look when you're graphing it. Okay, and that's going to come right from that absolute value of 4p, so right from your equation. All right. So if we're going to graph them or write equations for them, again, my suggestion, sketch and label what you're given. Locate and plot the vertex. If you're not given it, you'll have to find it. Determine the focal length p and the focal width, the absolute value of 4p. Use that focal width to locate the endpoints of that chord that goes through the focus. Sketch your parabola. And based on which way it's opening, you can decide what kind of equation you need. Okay. All right, so our first example. It says find the standard form of the equation for the parabola that has a vertex at 3, 4 and a focus at 5, 4. So take a minute and plot those 2 points. Make sure you label which one's vertex, which one's focus. Okay, and based on what we see, which way is this parabola going to curve or open? It's going to go to the right because it has to curve around that focus, yes? So if we know that it's going to the right, what does that tell me? If it's going to the right, it's a y squared kind. So opens right means y squared kind. It does have a positive p-value. Can we tell what the value for p is? The distance from vertex to focus, we went 2 to the right. So p is 2. Okay. And we were given the vertex, right? And so this is our HK point in our equation. And if you think about the equations, that's all you really need. If you know H and K and you know P, you can write your equation. Okay, so we said it's the y squared kind, which starts out y minus k quantity squared equals 4p times x minus h. Now, notice that h is always going with x, right? It's your horizontal shift, the change in your x coordinate. K is your vertical shift. That's the change in your y coordinate, so it's paired with y. Okay? So plugging things in, we know that p is 2. So in front of the parentheses here, 4 times 2, I'm going to have an 8. Yes? Now, students often put the vertex in the wrong spot. They see HK and they dump them in that order. But because this is a y squared kind, we need the y coordinate over here on the left. So the y coordinate of my vertex was 4. I need a 4 here. My x coordinate of my vertex was 3. It has to go with the x piece. Does that make sense? Okay. All right. Graphing by hand allows us to see the structure and relationships of the parabola and its features. If we need an accurate active graph, we can use the calculator. But we will need to solve the equation for y first. Now, one word of caution, do not rely on your calculator to graph these conics. Okay, you will be expected to know how to do them all by hand. The calculator is just going to be a backup to verify if you've done things correctly, or if you need, like it says, an active graph, you need to be doing something with that graph, some kind of application. Okay, so we're just going to look at what would we do if it's that y squared kind when we just had in our last example. How would we solve this for y in order to type it in our calculator? Because right now we have y being squared. Okay, so if we square it both sides, we've got y minus 4 equals the square root of 8 times x minus 3. What has to go in front of a square root? Yeah. Okay, then what would we do? Can we add the 4 over? Okay, so we end up with y equals 4 plus minus the square root of 8 times x minus 3. You also could put the plus 4 at the very end. You just want to make sure it's not in that square root symbol. Okay, that it would be on the outside. So we typically would put it in front. Now, to enter this on our calculator, we're going to have to separate it into 2 equations. So you're going to type in y1 is 4 plus the square root of 8 times x minus 3, and you're going to type a second equation in with the minus version. Okay, I'm going to pause the recording here, let you get that typed in. Let's see what you get. Now, what did you notice when you graphed it? It kind of looks like, on some of the calculators, it might look like there's a little gap in it, right? Because what it's doing is it's trying to graph the parabola with 2 separate equations, all right? The positive version is giving you the top part of your parabola, okay, that positive square root piece, and then the bottom part is giving you the negative version. You need to know that what it's graphing is a parabola and that those 2 branches do connect, okay? Questions on that? All right. So back to graphing some things by hand. In order to get our picture, one of the key things is we need to know where the vertex is, right? Can we tell that from the equation? So in this first example, where would my vertex be? Say it again. 2, 3. Okay, and again, watch that order, especially when it's the y squared kind, things are backwards, right? So you need your H value, your X coordinate, and then your Y coordinate. So we have a vertex at 2, 3. Okay. And then where would the, how would we figure out where the focus should be? In order to find the focus, we have to know what letter? P, right? We have to know P, that focal length. So from our equation, this -8 here is really taking the place of what? 4P? So P would have to be -2. Okay, so that tells me I'm going to go 2 units which way? Why do I know it's left and not down? Because it's a y squared, right? Y squared's open to the side. Okay, so it's the y squared kind. All right, so it's going to be a left or right issue. And because P is negative, we know it's going to open to the left. So we're going to go 2 units to the left to find our focus. Let me move where I go, vertex. Okay. Where would the directrix be if they asked me to find the directrix? It would be how many spaces? 2 to the right. Okay, so 2 to the right would put me here. Yes? All right, so my directrix would have the equation x equals 4, if I had to list that. The focus has coordinates, what? 0, 3? Okay, now, we want a really nice graph. We want it to be accurate. So we need to figure out the focal width. The focal length is 2. We figured that out. The focal width is the absolute value of 4p. All right, and in my equation, the 4p was represented with a -8. So the absolute value of -8 is just 8. That means the chord that goes through the focus is going to be 8 units long. And because it's symmetric, that means half of it's on one side, half of it's on the other. So I'm going to go 4 spaces up and 4 spaces down from my focus point. Okay, so 4 spaces up and 4 down. And now I have a couple points to aim at, so I know how wide to make that parabola. Okay, so go from your vertex through those points. I'm going to pause the recording. I want you to try the next one with the people at your table. Describe for me what you did to graph number 2. What was the first thing you found? Okay, we can find the vertex. From my equation, what's my x coordinate? Good, -1, and then the y coordinate? 5? Okay. Okay, there's my vertex. And what else do we get from the equation? We get p. So we know that 4p equals this 12, right? So p has to be 3. And is it x squared, y squared kind? It's an x squared, which means it opens up and down. And because p is positive, it's going to open up. All right. So we know it has to open up, and we know our vertex and focus are 3 spaces apart. Okay. So we can put our focus in right there. All right. Where would our, well, let's give the coordinates of the focus. Where did we put it? -1, 8. Okay. Where would the directrix be? If we went 3 units up to get the focus, we have to go 3 units down. And remember, your line is not going to ever touch your parabola, right? So we have 3 units down. It would be a horizontal line. Let's pretend it's a horizontal line. All right, equation for it would be y equals 2. All right, and then we need a couple other points, right? We need the ends of that focal chord. So 4p was 12, and remember we want to split that and do half on each side. Okay, so we're going to go 6 spaces from the focus. All right, and now we've got some points to aim at. Okay? Questions at all about the graphing? Can you find where the vertex is from the equation? Can you find where the focus needs to be? Where the directrix and how wide to make it? We good with those? All right. The last two switch. This time we're given some information. We want you to write the equation for it. Again, it's easier if you visualize what you're given. So in the first one, we are told the vertex is at 1, -2. And the focus is at 4, -2. So if we know our vertex is at 1, -2 and our focus went to the right, it means it's opening which way? It opens to the right, right? It has to curve around that focus. So we know it opens right, which means which kind is it? X squared or Y squared? Okay. We're given the vertex, so we know our H and our K values already. Okay? And from our picture, can we tell the distance between the vertex and the focus? It's how far? 3? So P is 3? All right, so we should be able to write our equation. We said it's the y squared kind, y minus k quantity squared equals 4p times x minus h. Okay? So plugging in what we know. If p is 3, we're going to have a 12 there. And now we have to dump in our h and k, being very careful that you put them in the right spot. So what goes in this first one with y? Okay, it is going to shift to a positive 2 because you're subtracting a negative 2. Okay, and then in with the x. Okay. Questions about that? All right, our last one here, we're given a little bit different information. This time they tell us the focus is at 0, -4. And they tell us the directrix is at y equals 6. So how far apart are those? From -4 to +6. How far is it? 10. So where would the vertex be? In the middle of those, right? So 5 units from either one. So we know our vertex has to be right there. Coordinates would be what? 0, 1? Okay. We also, from our picture, know that it's going to have to curve down. So it's which kind? Is it x squared or y squared? It's going to be an x squared kind. Okay, so we said vertex was at 0, 1. We know it's the x squared kind. And because it opens down, p has to be what kind of number? Negative. All right, and so p is going to be negative what? 5, right? From vertex to focus, we went down 5 spaces. Okay. Do we have enough to write our equation? Yes. It's the x squared kind. Okay. What is the h value? 0. Do I have to write x minus 0 quantity squared? No. I can just write x squared equals 4 times p. If we put a -5 in here for p, we get -20. And then we would have y minus 1. Okay. So focus today is on shifting that parabola so the vertex isn't at the origin anymore. Okay. Again, I want you to be memorizing this type of equation for parabolas, right? The x squared kind, the y squared kind. Okay. All right, assignment is listed there.